Hello class, today we're going to learn to evaluate functions. But first we're going to go back and review what functions are, okay, and how we can represent them and how we can identify them. We can identify functions 4 different ways. 1 is through a series of points, 2 is in a table, 3 is in a graph, and 4 is in a mapping. Okay, we did a lesson a while back that allowed us or gave us the ways to identify functions. And we know that the key thing in a function is the x value in a coordinate. Okay, the x values must be unique. In other words, they have to all be different. So when we look at this first one, we look at our x values inside this set of coordinates. We've got a 2 and a 2 and a 2 and a 2. They're not unique. So this is not a function. Okay. In the next one, in this particular series of points, we have a 0 and a 3 and a -5 and a 4. They are all unique, so this one is a function. In a table, we're looking again at the x values. So this is a horizontal table versus a vertical table. The x is on the top. So we look at 3, 3, 3, 3. So that means this one does not represent a function. Okay, on the next one, we've got 0, 4, 7, 6. So this one, all the x values are unique, thus this one is a function. In the last t-chart, we've got a 2, 5, 8, and 1. Again, all unique, so it is a function. Now for a graph, what we look for is what we call a vertical line test. Okay, so I'm going to draw a vertical line through the graph, and if at any point in the graph that line would hit more than one point on the graph, then it is not a function. So in this one right here, if I were to draw a line right here, it would only hit the graph one time. Okay, but if I were to draw a line right here, I would actually hit the graph 3 times. So if I hit it anywhere along the graph, anywhere at all, where it's more than one point, then it's not going to be a function. So this one is not a function. Now if I have a series of points graphed, then it's just a vertical line drawn through each one of those points. If it hits more than one point, then it would not be a function. This one, however, each line is unique, so this one is a function. So what about this next one here? Well, this next one, if I draw vertical lines down these points, every one of them only hits one point, so this one is a function. Right. Now on the next graph, this one, if I were to draw a line right there, I'm going to hit 2 points on the graph. So this one is not a function. Now mappings are a little interesting. Okay, mappings are nothing but this circle representing the x value of a coordinate and this circle representing the y value of the coordinate. So when we do a mapping like this, it's telling me that this -2 is going to go with a 1. So that would be our coordinate. Okay, this 1 is going to go with the 2. So that would be our coordinate. This 5 goes with the -4. And this -3 goes with the -2. Again, what I'm looking at is each x value mapped to a y value. Okay, mapped to a different, we can only have this x value mapped to one y. So we got -2 to 1, 1 to 2, 5 to -4, -3 to 2. So all my x values are unique. So this one is a function. Okay. Now on this next one, if I were to write these points out, we've got 5, 4, but I also have 5, not -1, 5, 1. So you'll notice that my x values double up. And the next one I got -3, -4, and -3, -2. So again, I have 2 x values here and 2 x values here that have 2 y values. Okay, so this one is not a function. Now if my triangles here went the other direction, where if I had this 4, okay, going to the 5 and the 4 going to the -3, that would be okay. Okay, we just can't have one x value mapped to more than one y. So that's kind of a review of functions. So today what we're going to look at is how to read and write functions and evaluate them. So here's kind of an example. Okay, the first thing we need to look at is what is function notation. Functions can be written in 2 formats. Well, the format here on the left is one that we are familiar with, the y equals format. where we have y equals 3x plus 5 and y equals 2x squared plus 1 and y equals x over 3 or y is equal to 2x. That's something that we're familiar with, where we plug in an x value, and it could be anything, and I get a y value out of it. Well, function notation actually gives you the value to plug in. Okay, so when we have a function format, we're going to have something called f of x, and that's how we read that, f of x, or the function of x. But this allows us to have multiple types of functions. You notice on the left, everyone has a y. This one has f of x and g of x and h of x and j of x. Okay, so we can have various functions to represent different things. And to evaluate those functions, all we're going to do is we're going to take whatever our x value is and we're going to plug it into the expression. It's as simple as that. Evaluating functions is very easy. So here we're going to evaluate this function, f of x is equal to 2x plus 5, for the following values. So basically all that means is that I'm going to take this f of 6, and I'm going to take this 6, since I substituted it in for the x value, I'm going to substitute the 6 everywhere I see an x. 2 times 6 plus 5, and then I'm going to evaluate it. So 2 times 6 is 12, plus 5 gives me 17. Now I change my value again. So I get f of 21 this time. So I'm just going to plug in 21. So 2 times 21 plus 5. Well, 2 times 21 gives me 42, plus 5 gives me 47. Okay, same thing for negatives. Got f of negative 3, so that's going to be 2 times negative 3 plus 5. Well, 2 times negative 3 gives me negative 6. Negative 6 plus 5 gives me negative 1. So in essence, all we're basically doing when we do this is we're plugging in each value for x, and we solve or type in the equation into y equals and look at the table. Okay, so all we're doing basically is plug and chug, just plugging something in. Now, how could I use this? Well, here's kind of a silly example of some dog groomers where we could use the y equals format or the function format. It says 2 dog groomers use the following equations to calculate the total cost, y, depending on the number of hours spent with each dog. So barking lot grooming uses the formula y is equal to 5x plus 3, or b of x is equal to 5x plus 3. Okay, Tidy Paws uses the equation y equals 3x plus 21, or p of x is equal to 3x plus 21. Where Barking Dog, we used a b to represent the function, and Tidy Paws, we used a p to represent the function. Okay. So what if we wanted to figure out how much would it cost if it took, at Barking Lot Grooming, 3.5 hours to work on a dog? Okay. Well, in this particular one, we would take the 3.5 and we would just plug it in. So we'd end up with 5 times 3.5 plus 3. So we'd multiply that together, and I believe it gives me 20.5. Okay, but if we know that we're dealing with money here, we're looking at how much is it going to cost. This is actually $20.50, and that would be the correct way of writing it. Now the next one says, what if we went to Tidy Paws and we only did 2 hours? So that's what this one stands for. Use the p function in order to do this one. So this would be 3 times 2 plus 21. So 3 times 2 gives me 6, plus 21 gives me 27. So all the function, to evaluate a function, all we're really doing is taking whatever value is inside our parenthesis here and plugging it into the equation. Now that's half the lesson today, because there's one other thing that we've got to look at when we're dealing with evaluating functions. And this one, it's giving me the x value. But what if I have the answer to the problem and I'm trying to find x? It says, what if a customer at Barking Lot Grooming paid $19.25 to have their dog groomed? How many hours did it take the groomer to groom the dog? So this time it says b of x is equal to $19.25. This is the answer. And what I'm trying to get back to is how many hours did it take, which is the value of x. Okay, so what we can do with this particular thing, since I know b of x is equal to 1925, I can actually substitute the 1925 for the b of x. The b of x, 1925 is equal to 5x plus 3. And then I use algebra in order to solve this. So the first thing I need to do is get rid of this 3. So I'm going to add a negative 3 to both sides. So that gives me 1625 is equal to 5x, and then I divide both sides by 5. And when you divide that, I believe you get 3.25. Then we look back at our problem. It says how many hours did it take? So my label on 3.25 is hours. And that's how we evaluate functions, okay, for given values, or find the missing value for a given answer. So I'd like for you to work on this assignment. And you'll notice on this particular assignment, we've got 4 functions that we're going to do. We've got an f function, we've got an h function, a c function, and a g function. So for each one of these problems, you're going to use the appropriate function to solve. So like number 1, it says that we have f of 12. So that means I need to use the f function. And wherever I see an x, I'm going to plug a 12 in. So we would do 10 times 12, and then plus 8. Okay, so 10 times 12 gives me 120, plus 8 gives me 128. Now, number 2, it says I'm going to use the c function. Okay, so I will take my c function and plug 2 in wherever I see x. So in this one be 25 plus 5 times 2, because my value of x is 2. And then I just do the math. Okay, 5 times 2 is 10, so 25 plus 10 gives me 35. And that's all we do on this particular assignment. So until next time,